Right, I think should we go? Good evening. Welcome. It is fantastic to see a room full. Thank you so much. My name is Conrad Banks. I'm the chairman of the local branch, the Bristol branch of the Royal Aeronautical Society. So on behalf of the Society, on behalf of the branch, welcome. It's great to see you all. Also welcome on behalf of the University of West of England, who are kindly hosting again this evening. They do a great job every year, and I'm sure, again, this year will be fantastic. Third welcome. This is a first for Barnwell. We are live streaming this on the internet, on YouTube. So a number of people are logged in who couldn't make the lecture. It will also be available afterwards if you want to catch up. If you missed something, you can all have a look later on. So we're moving into the 21st century here in the Bristol branch. A word about this evening. A few housekeeping announcements. There are no fire drills planned this evening. If the fire alarm goes off, believe you me, you will hear it. We are spoilt for exits. Prime route is out of this door and meet in the car park where you came in. If that's blocked for any reason, there's a real fire, you have exits at the back and you have an exit here. Turn left and follow the green signs. So don't worry on fire front. Please, says he, checking himself, turn your phones to silent. It's very easy to forget. Obviously, we don't want to interrupt Mark during his lecture, so please put your phones on silent. If anyone needs the restroom, straight out of these doors, turn left, and you'll be covered in that event. Just to confirm the arrangements for this evening, a number of you are staying for dinner. You should know who you are. So after the lecture, we are going to move next door. There will be a bar service for an hour or so, half an hour or so, and then we'll sit down shortly after 8 o'clock. And those of you that are here for the lecture only, I really hope you enjoy it, but obviously after the lecture you will need to leave. Sorry. That was a bit mean, wasn't it? You can encourage your companies to sponsor more tables next year. Right, turning to our lecturer this evening. It gives me great pleasure to welcome Mark. Mark's been a colleague of mine in the past, quite a long time. So I'm just going to run through a very quick bio for Mark. Mark Thomas was appointed the Managing Director and CEO of Reaction Engine Limited, which is based in Culham, Oxfordshire. He was appointed in May 2015. Before joining Reaction Engines, Mark graduated from Cambridge University with an engineering degree, and he spent 25 years working in the fantastic company of Rolls-Royce. He was based down in Bristol for a number of years, and that culminated as the chief engineer of the EJ200 in the Typhoon, RB199, Ador in the Hawk and Jaguar. He then moved up to Derby, and he was the chief engineer on the Trent 900, which is in the Airbus A380, very high-profile program. He was also, prior to that, the technical director of Eurojet, based out in Munich. So he had a fantastic career in Rolls-Royce, and it culminated with a position of chief engineer for technology and future programs, which is all about future technologies. So from Rolls-Royce, he took up his current role with Reaction Engines, and he's leading development, and you're going to hear about this evening. He's leading development of the truly unique SABRE, synergenic air-breathing rocket engine concept. And it's probably best if I hand over to Mark now, and he's going to tell you all about that. So Mark, welcome. Thank you so much.
Well, thank you very much, Conrad, and thanks for massively over-exaggerating my capabilities and qualifications. Appreciate that. Also fantastic, this is a bit of a homecoming for me, having spent around 20 very happy years actually working in Rolls-Royce in Bristol on military programs, and probably won't talk about the 6 years in Derby, which was maybe slightly less enjoyable, but great people. Difficult products, but no, great business overall. Real privilege to be able to chief engineer some of Rolls-Royce's engines. So engines have been a big part of my life, and this is no exception because this is the new chapter for me, really. Also delighted that we've got a room full of people. Last time I saw a room this full was a conference at Harwell, the UK Space Gateway, if you didn't know. But I hadn't realised I was just the warm-up act for Tim Peake, and I was standing between everyone and a real astronaut, so I kind of just had to make a quick exit at that point. But I'm going to talk a little bit, well, I'll talk about the company to start with. I'm going to tell you a little bit about what's happening in the space sector, which is a sector I stepped into just 2 years ago, exactly 2 years ago, and it is incredibly exciting, exhilarating, dynamic. Every day there's something in the press about space. It's a bit of a misunderstood sector because until you're on the inside, you don't actually realise what's going on. You have a perception, but when you're on the inside, it feels very different and it feels very, very special. It's a very welcoming sector as well, space. The companies work very well together. So I'll talk about that and then talk about where we're going as a company, which has been a thrill over the last 2 years, a real roller coaster ride, and a complete blast, and hopefully we can continue in that manner, maybe with a few less bumps. This is the SABRE engine on the screen. As Conrad said, synergetic air-breathing rocket engine. It is a rocket engine, but it has some of the qualities of a jet engine, so it combines the two systems in one. It's very flexible, it's very versatile, it has a huge speed range and the potential to take vehicles to orbit. So before any of that, because you've given up a very sunny Tuesday evening to come and listen to me, I'll show you a quick video about the current state of the art in launchers. So pretty dramatic, compelling stuff. I mean, that is a big industry and a big company there. Arianespace really leading the way in many respects. I mean, hugely impressive products. But I'm going to tell you what, going back to Tim Peake, it takes some courage to sit on the top of one of those fireworks when somebody lights the bottom of it. And if you ever get the chance, if you can listen to Tim Peake's story of his trip to the space station, you know, that launch sequence when you are on the top and the re-entry are incredibly violent and dramatic events. In fact, in his words, it's hard to tell if you're experiencing a normal re-entry or a catastrophic failure. You know, but that is the way we get stuff to orbit currently. And yeah, rockets are interesting things. You know, launchers, it's the only form of transport that you use once and then you throw it away. You know, and there's clearly efforts to change that and move to a new paradigm, and that's really with the space that we fit in. So let me tell you a bit about the company first, just a quick overview update on reaction engines, because it's been around a while. You know, it's kind of, you know, it's been on a slow burn for many years, from emerged out of the back of the HOTOL program in the late 1980s, founded by three outstanding individuals, Alan Bond, Richard Varvel and John Scott, and Alan and Richard are still with the company. John unfortunately passed away, and they did some amazing things, frankly, in the first few years, and we've really built a company off their original vision and taken it into new territory. So right now, today, we're a company of around 120 people, and that changes on a daily basis, virtually. I mean, we are recruiting 1 to 2 people a week at the moment, so we're on a big recruitment drive. The company, as you can see, has more or less doubled in the time I've been there. Brought in an entirely new leadership team to take the company from its research activities into true development, product development, and we've got a very broad skill set. And as a company, we're very diverse. We operate over 4 sites, 3 in the UK, 1 in Colorado in the US, but the company, so it's a very young company, very dynamic, very energetic. 10% of our staff are apprentices from our own apprenticeship program. 25% of our engineers are female, which I think is great, and demographically, I say, we're biased towards the younger end of the scale. It is a very exciting place to be, you know, very dynamic and very pacey. We get stuff done quickly, and that's the sort of culture that we're trying to cultivate there. hang on to as we get bigger. That entrepreneurial way of working, but with the discipline of an aerospace company. In terms of our sites, just a quick tour, based largely on the Science Centre in Culham, which is owned by the Atomic Energy Authority. It is the hottest place in the solar system, I'm reliably assured, because of the big building in the middle, if you can see it, which is the Joint European Torus. It's a fusion reactor project, and it's 230 million degrees centigrade at the core, which is pretty impressive. And if the lights do flicker, it could well be the guys in Culham, because it consumes 4% of the national grid when they switch it on. So that is an impressive operation, and around 1,500 to 2,000 scientists on site, scientists and engineers. In addition to the AEA, there's about 30 or so startup businesses, and we're in that category with the next biggest company on site. We do our design, manufacturing, testing there. We also have a rocket test facility over in Buckinghamshire. And this is the home of rocket testing in the UK. It's the rocket propulsion establishment. It was been testing rockets and rocket engines actually since 1947. So lots of history there. Less well-developed site, obviously, because of the rocket testing and the fuels that are used. It was influential in the Blue Streak, the Black Arrow, which was a UK launch capability at a point in time. And it's a site where we're actually about to build a new test facility for the SABRE engine. So we did a groundbreaking a few weeks ago, and it will be a unique facility, unique in the world, actually. We have a nice little manufacturing operation with vertically integrated. That's a bit like SpaceX, but on a smaller scale. All our manufacturing is virtually done in-house, precision machining, fabrication. And I can only find the travel brochure view. We have a really nice office in Colorado. So Colorado, initially for convenience, the guy that runs that office joined us from Lockheed Martin Space Systems. He was one of their chief system architects. So he was designing space planes for Lockheed Martin and thinking about that next generation of space planes and high-speed vehicles. But it is actually the second largest aerospace state in the US, and there's a huge number of industry players out there, as well as Space Command, US Space Command. And it's the home of NORAD, so I guess the only downside is it's number one on the target list. If there ever is a third world war, it's strike option 1. So, but it's a great place to be, and an operation that we're going to build up significantly this year. So let's talk about space a bit then, my views. So, when I initially thought about space or was thinking about stepping into this sector, these are the images I had in my mind, these iconic images of the Apollo astronauts, the Saturn V rocket, space shuttle. And anybody know who this guy is down here? Somebody, yeah, well done. So most people say Chuck Yeager, but it's Neil Armstrong. So X-15, a remarkable program. Nearly 200 flights conducted with the X-15, many of them hypersonically, resulted in Air Force, resulted in pilots getting their astronaut wings, effectively becoming the creator of the astronaut program. And we draw a lot of inspiration from the X-15, a hypersonic vehicle that can operate over and over again in a very aggressive environment. It did have lots of challenges, but it's an amazing program and success story. But space is really more in this camp. Space touches all of our lives every day. If you used a sat-nav to get here, I did follow Conrad's instructions, but I also used a sat-nav. Then you're reliant on satellites, obviously, mobile phone comms, you watch live sporting events. The emergency services would not operate without satellites. The time signal that sets the stock exchange, it relies on satellites. If you can imagine a day or even an hour or even a few minutes without space, the world would be a very different place. The world would stop spinning very, very quickly. Space affects all of us. And in terms of the UK contribution, we're in a growth industry. So the UK space sector is growing at about 10% a year. It was worth nearly £14 billion last year in terms of direct value, and it generated £250 billion of indirect value in terms of jobs and industry and downstream services. So it's a really important sector, and the UK set a target to grow and claim 10% of the world market by 2030. So that's a £40 billion a year industry that we're after. And one of the big developments is really in satellites. So 60 years ago, this guy was pretty lonely up in space, Sputnik up there on its own circling the Earth. And it created the start of the space race. But today, if you can see that, there's over 1,500 satellites in orbit, and it's increasing on a weekly basis. So just a few months ago, the Indian Space Agency launched 104 satellites on a single rocket. This is the industry is growing at a remarkable rate. That's satellites. There's other stuff up there as well, including space debris, which is becoming more and more of a problem with some of those parts that are jettisoned off upper stages of rockets, and satellites that have failed or reached the end of their life. So it's a pretty busy place up there, and getting busier all the time. But one of the big drivers and the thing that's really fueling that increase in satellites in orbit is the demand. Demand for services. And by services, I mean, every time you open an app, every time you watch Sky TV, those are the services I'm talking about. But satellite technology developments, satellites used to be, and many of them are, the size of London buses. They were huge and required very, very big launches. And there are still satellites in that territory. But increasingly, we're looking at satellites that are smaller than the size of a toaster. Okay, so CubeSats and nanosats. So the UK has a great lead in this sector. We have two of the top companies in the world, and Clyde Space is just a fantastic example of a company that saw this coming and was quick out of the blocks developing the technology for small satellites. But these guys have a tough time, because if they want to get these things into orbit, they have to hitch a ride on a big launcher. If there's space in the payload bay around the other cargo, the other bigger satellites, they have to hitch a ride. So there's no guarantee of when they'll get a launch slot. It's very much dependent on availability in space. Or they have to commission their own launch, which is an expensive activity. So typically a launch would be of the order of $100 million for a big one. But there are efforts to bring that down through reusability of the first stage of rockets and smaller launchers. And there's a great outfit in New Zealand, Rocket Lab, that are promising $5 million launches, and that's a huge shift in the industry. But launches are interesting because actually, although they might change in shape and size, and they really do go back to V2 technology, V2 rocket technology, there's been very little change over the entirety of the launcher industry or the space program in terms of launcher technology. So relatively expensive. I would say we tend to talk of a $10,000 per kilogram of payload to low Earth orbit. And obviously people like SpaceX and Elon Musk are changing that parameter, so maybe halving that cost. There's a long lead time for a launch in terms of preparation. There's a huge infrastructure required, months to prepare. Not hugely reliable at the moment, so you wouldn't accept that type of failure rate on an aircraft of any description, even experimental aircraft, of a 2 to 5% failure rate. And they're very complex. You have lots of bits that could potentially go wrong, lots of bits to them. The feeling is there has to be a better way. It's inconceivable to think that we'll live with this way of doing the job forever. So what are the alternatives? Well, here's a few examples. So I mentioned Elon Musk, SpaceX. So vertically launching and recovering at least the first stage of a rocket offers significant cost savings, and so that's recovery. And if you can reuse it, then you're on a good trend. So vertical launch and recovery is clearly a thrust of people like SpaceX and Blue Origin, but air launch is an increasingly interesting sector. So we have Virgin Galactic with Launcher One. We have Orbital Access, UK company that's actually offering, going to be offering a service in this territory. And just recently, May the 31st, Paul Allen rolled out the Strato launcher, or the, Strato Launch Systems rolled out their carrier aircraft, this beast of an aircraft, over 500 tons in weight, with a wingspan that's equivalent to the height of a Saturn V rocket, if you were to lay that on its side. A very, very impressive device to carry a more conventional rocket nearer to orbit, because really most of that mass of a rocket is to get it off the pad. That is pretty much where the mass goes. So 70% of a launcher, and take an Ariane 5, that's an 800-ton launcher, 70% of that is liquid oxygen, and most of that is consumed in getting the thing off the pad. So it's so in broad terms, it's not too specific. So there has to be a better way, and if you can already be closer to orbit, then that's a good move. And actually in Colorado, there's they're advertising a spaceport in Colorado, and they have a nice little strap line, which is the first mile for free. We're already a mile closer to orbit in Colorado. And I was out there just recently, and I can vouch for that, because the air is certainly a lot thinner on the tops of the mountains in Colorado than down here in Bristol at this level. But so we do see these trends, we see these developments, we see these things happening now in terms of reuse. And the airborne launchers are coming hot on the heels of that. But really what people want to see is more aircraft-like operations. So here's a slight variation on that theme. It happens to be one of our own concepts, Blue Boomerang. So this is vertical launch again, but you recover the first stage, and you recover it a bit like a space shuttle, effectively. So it has wings, it has capability to glide back to an airfield, and if you wanted to, you can actually provide some propulsive power to enable it to have some diversionary capability as well. But that's a means to get things back quickly, horizontal landing, more aircraft-like, and then you can turn that whole vehicle around much more rapidly. Still multiple stages to orbit, and that's obviously an area that the SABRE engine is intended to address. This is not a SABRE-powered vehicle. So you think, okay, beyond that we're into brand new territory, surely? Well, not quite, because here's some concepts from past history. Some pretty amazing concepts, actually. So, as I said, the UK did have a launcher capability. We had a launcher capability. In fact, the only nation that had a launch capability, and then decided not to pursue it. But that technology and that knowledge and that know-how was part of the inspiration for the Ariane program. So Europe has a launch capability that's phenomenal off the back of some of that experience. We did early work on HOTOL, and you're familiar with HOTOL, and the guys that worked HOTOL on the engine side were the founders of reaction engines, and their vehicle of choice was Skylon. But the one I really like is the Mustard, because it's just got the best acronym ever. So this is the Multi-Use Space Transportation and Recovery Device. Yes. So it took some courage to, I think, put that one out there, by BAC. And it's amazing, actually, because it's 3 lifting bodies, all of which return to Earth. So it operates in this sandwich fashion, and the first 2 push the third one in close to orbit. The third one goes into orbit and can be recovered again. So a fully recoverable vehicle based on 3 very similar lifting bodies, and unfortunately that was also cancelled. It was just way ahead of its time, as was HOTOL. But if you do look at the space shuttle, it's not dissimilar in terms of, because there was a UK-US tie-up during the course of that study, and some of that learning potentially did feed into the space shuttle program. So let's just have a look at the holy grail, if you like, which is single stage to orbit. So for many years, Reaction Engines was pursuing the Skylon spaceplane, and this is Skylon, and that is an ultimate application of space technology in terms of launch as a single stage to orbit vehicle that operates like an aircraft that you can turn around every 24 to 48 hours. It's a cargo delivery system. So if we ever find ourselves, and I think we will, in a territory of building things in space, then this is the sort of vehicle you need to be delivering cargo, to enable that infrastructure, to enable that onward journey to Mars or wherever. It's something you can turn around quickly, that operates in a fleet. But it is very, very challenging. There's no doubt that this is off the scale in terms of challenge. And in terms of our roadmap, sits towards the end of our roadmap. But one day when people pull this off, this is the way to access space, single stage to orbit. And we've done many studies on Skylon, and we've done lots of research and technology activities on particularly the structural solution and the material solutions for this sort of a vehicle, its operational characteristics, its trajectory. But actually, as a company, what we're now focused on is some nearer term opportunities that we see emerging as a result of those changes in the space sector. So I should talk about SABRE and what it offers. So if you're not familiar with SABRE, I'll say again, it's an air-breathing rocket engine, which is unique. Combines the characteristics of jets, engines and rocket engines in terms of efficiency and performance. And it's enabled by a smart piece of technology and a clever thermodynamic principle. So the engine has two modes of operation, air breathing and pure rocket mode. This chart kind of illustrates the air breathing mode of operations. This is between standstill and 5.5 times the speed of sound, so Mach 5.5. At those sorts of speeds, the air, when it's slowed down by the intake, gets very hot, so circa 1,000 degrees centigrade. So to do anything sensible, you need to be able to cool that air very quickly. And we've developed a technology, heat exchanger technology, that enables us to take air from 1,000 degrees to ambient conditions or sub-zero temperatures in a fraction of a second. So it's a very powerful, compact heat exchanger. And then you can do something with that air, and you can use it as an oxidizer. That's the trick. You're trying to use that air as an oxidizer and save some of that enormous mass on a conventional launcher. You compress it, and you push it into a combustion system, and you mix it with hydrogen fuel. But the other really smart thing on the engine is once you've taken that heat out, then you have two options. You can dump it, or you can use it. Dump it into hydrogen fuel, which is very cold, or use it to do work. And we use it to do work. So we use it to drive turbo machinery, drive turbines effectively. So we extract heat using helium that's been cooled by hydrogen, so heat from air, and we use that heat energy to drive turbines which keep the machine operating. And it makes for a very efficient device. Now this is conceptual, and the technology building blocks are maturing, so we're at TRL 3, 4, and 5 on some of the technologies. And then you have to integrate it in a very smart way, because you can easily lose that performance benefit in the integration job if you're not careful. So it's about cooling, arguably regeneration of heat, and smart integration. And then you have a very powerful and compelling offering, which in performance terms really does stack up. So this is probably the most sciencey chart in the pack, but speed across the bottom, Mach number from 0 to 10 times the speed of sound, and efficiency and thrust to weight ratio. Up is good on both charts. So if you look at SABRE, red line, against other types of propulsion system, jet engines, ramjets, scramjets, and a pure rocket, it really holds its own in terms of both efficiency and thrust to weight ratio over a very wide speed range. The reason the line goes dotted is there's a point in time or point in speed at which you have to go to a pure rocket. You cannot manage the temperature sufficiently to enable you to continue in that air-breathing mode, and that's around about Mach 5.5 where you switch to a pure rocket in the same device. So you do have an engine that can go from standstill to actually 25 times the speed of sound, orbital speeds, orbital access speeds in a single unit. That is hugely more efficient than a rocket for a large portion of that flight, orders of magnitude more efficient than the rocket that sits at the bottom here, and really holds its own against those other forms of propulsion. So for a vehicle designer, it's pretty attractive, how you can integrate this single propulsion system in a very optimum way, and it can drive some extraordinarily powerful vehicle concepts. I know, just quote at the bottom there, a two-stage to orbit system based on SABRE could be maybe game-changing. That actually comes from a customer, a very big customer over in the US. And these are the vehicles we're studying at the moment, ourselves and with other organisations and agencies. So, two-stage to orbit initially, where SABRE would power a first stage. So this is your carrier, effectively, for your upper stage, which is the cargo. The satellite is in that upper stage, and you're trying to make that upper stage as small and as cheap as possible. It's the expendable part. It's the bit that you're going to throw away. So make it as small and cheap as possible, which means you have to get as close as you can to the staging point, as far up in altitude, as far up in speed as you can with that first stage. And SABRE enables you to do that. We can get much closer to a sensible staging point. And because we save so much in terms of mass, we can drive that back in as design freedom, and we can design a vehicle which has wings and other capabilities. So it is more aircraft-like. It is what the industry is starting to demand in terms of a capability. Lower cost, much more responsive, high frequency or cadence operation, and more reliable, because if you do have a problem, you can actually fly the thing. You can actually take it to another airfield. You can divert. You can, if you have an engine out on takeoff, it will still fly. And we're not the only ones that think that way, because there's a concept from another organisation here, SpaceWorks, and there are many, many more that I could have littered the page with. They all look very similar, by the way. They all look very similar, and I guess you could say they're a slight variation on the SR-71 Blackbird, but that's where hypersonics drives you in terms of a design style. And we keep Skylon in our minds. It is on the roadmap. It is, say, the holy grail, the ultimate application of the technology. And I hope we do get there, because it's a remarkable concept. But SABRE has, I've spent all my career in the aerospace industry, and it's interesting when we talk aerospace, we kind of mean the aircraft industry. We sort of forget the space part. There's a few exceptions. I have to say the Royal Aeronautical Society is really, really good at reminding people that it's both parts. And the Royal Aeronautical Society magazine does contain a good amount of space articles and interest, and I think that's really, really something they should be complimented on, because most people think aircraft industry when they're talking aerospace, but let's look at aircraft while we're here. So SABRE can offer something in terms of aircraft as well. So we're talking very high-speed platforms. The top concept there is a concept that Airbus have worked up with us. It's very visionary, it's very exciting, it is inspiring engineers to go and do amazing things, and that's the reason they've put that out there. It's a hypersonic civil aircraft, effectively. As was our own design down here, LapCat, that was much studied. And there are other things potentially emerging in this arena. If you can go very fast, then and anywhere in the world in 4 hours is a really exciting prospect for any of you that travel regularly long haul. But the ability to go very fast, it does bring you other things, being survivability being one of those things in the defence arena, as well as flexibility. And the beauty of the SABRE engine is you can have an optional suborbital capability, which is something that is beginning to be explored in terms of concepts of operation. So I'll show you a little video that less than a minute, I think, that BAE Systems put together. Just to, they allowed their designers to run free a bit on what they could do with SABRE, and this is what they came up with. Okay, so they had a bit of fun there. That popped out just before the Farnborough Air Show last year, actually, and I'm relieved it was dropping supplies. So we are funded to develop commercial space access technologies largely, but speed gives you responsiveness, it gives you survivability, and that's important for those sorts of applications. In terms of where we are as a company, in terms of our technology, we've done a lot of work with heat exchangers. So this big pre-cooler that sits up front in the engine is something that we've actually demonstrated to a level on our test site in Culham. So we've had that operating over a number of years on a jet engine, demonstrating its cooling capabilities. So we've been down to cryogenic levels hundreds of times and demonstrating some pretty novel technologies like frost control, where you can basically prevent the thing becoming a big ice cube within a few seconds and just manage the formation of ice and ensure that the cooling is happening without any risk to the engine operation. So that's been a really successful demonstration that was pulled off by a very small team. The entirety of that, design, make, assembly, building the test facility, conducting the test. It really shows the power of demonstration. That actually unlocked some significant funding for the company. So the company, in terms of funding, was built off the back of private investment. So we had some very generous and very inspired investors who are extremely loyal, in terms of they started on this journey a long time ago. And we've moved more recently into the world of government funding and also industry investment. So just in a nutshell, in the last 3 years, in the first 23 years, we raised £35 million, which is pretty impressive, a small company. And in the last 3 years, we've raised £90 million. So we have quite a lot of assets and ability to now go and make this stuff happen. So the pre-cooler does this job effectively. Simplistically, takes hot air, 1,000 degrees centigrade, cools it to minus 150, or ambient conditions would be fine, in a fraction of a second. It's a really impressive device. Now, to prove that fully, we have to take a unit to basically a hot wind tunnel, a hot facility where it can be exposed to air of 1,000 degrees centigrade, which we don't have on a regular basis here in the UK. So that is a big milestone for the company that's coming up in the next 8 to 10 months. We have had to invest a lot in manufacturing capability. This is a really impressive piece of kit, actually. It's a vacuum furnace that we've designed ourselves, manufactured by Consark and installed, and it is a super piece of kit. This is a ultra clean, ultra high vacuum facility for joining heat exchangers, which are so these heat exchangers contain many kilometers, hundreds if not thousands of kilometers of tubing that's a millimeter in diameter, with wall thicknesses of less than 30 microns, containing high pressure helium, 200 bar pressure helium, and they have to be joined in a completely leak tight way to survive in this very aggressive environment. And it's a difficult alloy to handle, so we needed to make this investment. The second thing I signed off when I joined the company, the first was a coffee machine for the engineering office, which was absolute priority. Yes, a good coffee machine for the engineer. So, and then a vacuum furnace, which was a eye-watering moment, I must admit. But it's just been phenomenal, and we're doing work for other companies. And most recently, we actually tested in our vacuum furnace a probe for the European Space Agency's solar orbiter. So we replicated its experience of orbiting the sun in our vacuum furnace, and that was a really nice thing to do, and great for the team to be part of that. So it spent 3 days in our furnace being cycled effectively. And the demo was very successful on the pre-cooler. So over 500 tests, many of them to cryogenic levels. We demonstrated frost control, which is an unbelievably clever technology, actually, that was developed by Richard Varvel and Alan Bond. And it's a classic example. I hope they do write a book one day, and how you just persevere and don't ever give up. They must have had, over a space of about 5 to 7 years, maybe 50 attempts at fixing this issue. Lateral thinking, trial and error, building their own rigs, working on a shoestring at that point in time, but solves this problem that has actually stumped many big agencies and companies that have thrown hundreds of millions of dollars or pounds at that same issue, and something we value very highly. And this met all the objectives of the European Space Agency. The European Space Agency are a really tough customer, by the way. They give us, they provide all the technical oversight on the programme on behalf of the British government. They have a very robust and extensive technical team that spends almost every week with us, and just last year we went through a major gated review with the European Space Agency, which was a huge achievement for the team. Bear in mind we are a small growing company, so growing every week, so you can't get everyone in the room and say, right, this is it for the next 3 years, because there's 2 or 3 new people in the company the next week and the week after that. But they did a phenomenal job, actually, with a panel of 11 technical experts from the European Space Agency over a period of 2 weeks, going through every single detail of the programme and 75 technical reports, and picked up about 200 actions, which at the time I thought was awful and complete. But a similar company went through the same experience, much more established company that's been in the sector a long time, and they had over 3,000 actions for the same gate. So we did remarkably well. We've closed out all the actions. We're in a good place with the agencies. So we do a lot of technology development in the programme, heat exchangers being a key element. One of the attractions for me in joining the company, I had no intention of leaving Rolls-Royce. I was very happy in Rolls-Royce, but did get a tap on the shoulder, and SABRE was too good an opportunity to miss the chance to be involved in the high-tech growing company. But the technology I knew had wider applications. So I can't really tell you what we're pursuing at the moment specifically, but in terms of heat exchangers, we are working in these territories. We have heat exchange. We're not going after the heat exchangers business. It's far too aggressive. It's far too commercial. But we have heat exchangers that are high performance. They're very compact. They're extremely lightweight because of the space requirements, where a gram saved on a heat exchanger converts to hundreds of kilograms of payload at the top end. So we're looking at things like onboard power generation, the ability to use heat energy in different ways, satellite thermal control, improving aero engines. Good to see some Rolls-Royce faces in the audience. There's definitely an opportunity to get heat exchangers into aero engines. Been avoided because those things have been big and heavy, and architecting them into in an engine it's just not traded off. It's just not paid back. But we believe we're in the right territory, along with motorsport, hybrid electric vehicles, and novel cycles for particularly power generation, which is a very, very interesting area. So just on heat exchangers, we see great potential in building up a technology portfolio business to go make some of that stuff stick. And recruiting a new head of business development, if anybody's interested. So, we've also done lots of work on combustion systems. We have 3, not happy with one combustor in the engine. We actually have 3 in the SABRE engine, a pre-burner that gets the thing going and maintains the right temperature for the thermodynamic operation when you're not at high speed. A main air-breathing combustion chamber and ramjet system that operates in a part of the mission where you have excess air, effectively, and you can make use of that in a ramjet system. And integrating that stuff is really challenging, but these are some of the test activities that we do on a regular basis, where we're testing both combustion chambers and burners as well as rocket nozzles. The nozzles are pretty smart because you can go and buy a rocket nozzle today, and there's plenty of companies that do rocket nozzles, but they're single shot. Typically they're single use. Maybe you'll get 2. If you're lucky, you might get 3 or 5 uses from a rocket nozzle, but classically they're single use. Ours are designed to be multi-use. Hundreds of operations. That's one challenge or opportunity, but the other is you have to operate across a very wide speed range and in these 2 modes of operation, air breathing and rocket mode, and those characteristics are very, very different in terms of temperatures and pressures. So achieving that in a single device is a breakthrough, actually, frankly, and the engineers that have worked these solutions are young, bright engineers who do a lot of work empirically. So they will sketch something on an envelope. We will get it manufactured in our in-house manufacturing facilities, and we'll get it on a rig by the end of the week. And we'll get that tested, characterized, and we'll feed the CFD machine and the design tool set with that data. So So I think what they really love is the ability to turn this stuff around quickly. It's almost faster to do it empirically at the moment than it is to build up the models, the sophisticated models to do it on the computer. And we do a lot of work with 3D printing as well, as you'd expect us to, because this is really opening up the design space for everybody. So this next one is a black screen, but something does happen eventually, and it's a little bit noisy from memory, but just one of our short duration rocket firings. That's a little pop at the end there. So, it's a great day out of the office, going out to fire a rocket. It's really good fun, actually. These things are scaled down. They're the size, actually, diameter-wise, the diameter of a dinner plate, but they generate the thrust of an EJ200 engine, so it's quite impressive, actually. And I've had to pay for... No, I haven't had to pay, actually. We've broken about 20 iPhones when we've had visitors watching rocket firing, because they all want to film it, and we all warn them it's going to be noisy, and they all drop their iPhones when the thing starts up. So, yeah. And then if I step into a world that's more, I thought was more familiar to me, coming out of Rolls-Royce, living in the world of jet engines and turbine machinery, I thought, well, here's something I understand. I don't know anything about nozzles, rocket systems, rocket engines, but I do know turbine machinery, and then I'm faced with, but this is not normal turbine machinery. We need to design and make a helium turbine. If you're in that world, that is a very different beast to an air turbine, a turbine in a jet engine. This is a device that has, because of the operating pressures, which are very, very high, 200 bar entry, many stages. It's sewing machine type levels of engineering in terms of the size of some of the turbine blades. Tip clearance becomes a major issue. Bearing loads become a big challenge. And helium is not an easy thing to contain. Helium will find a way to escape if it can. So some of the sealing solutions have to be really smart. So we're working with companies to develop and deliver these solutions, because we actually need real hardware, because we're moving towards a point at which we need to demonstrate this stuff. But very challenging, because it's actually outside the design space of almost everybody that we've spoken to. It's a real stretch. And where do we go next? Well, you do need to step into the world of hypersonics and space, knowing what you're stepping into. It's a really challenging environment. If I just take hypersonics, the US has been researching in terms of actually flight testing hypersonic vehicles, devices for over 50 years. Currently pursuing scramjets, as you will see in the press, big amounts of money being spent on scramjets, and they will have their application. But in every sense, this is super challenging. The structural solutions needed, the novel materials required to cope with the heat challenge, so the heat barrier, the aerothermodynamics, the control of these vehicles, and also the propulsion system and the choice of fuels. It's all, many respects, alien territory, and therefore should actually command high prices, high cost in terms of design and development. We do think we have an advantage, which is our engine, because it's jet engine-like, can do most of the development on the ground. Behind the pre-cooler, the rest of the engine actually doesn't know it's traveling at hypersonic speeds. You've taken that heat out of the equation, you've taken the heat away as a problem, and the compressor will quite happily believe it's sitting normal conditions in the atmosphere, operating very much like a civil aero engine compressor. So in theory, we can get there faster, because we can do a lot more on the ground, we can do it more affordably. And that's a real attraction. So if I go talk to agencies who might be able to fund these sorts of projects, and you say we're in the world of hypersonics, the normal response is we'll come back in 20 years when you've demonstrated it. So if you say, well, we'll come back in 4 years when we've demonstrated it, then they're pretty much over the table wanting a piece of the action. And that's really what we intend to do. So we're setting off on this mission, effectively, where we're going to demonstrate 3 major elements of the engine in the next 4 years or so. The pre-cooler, which we're going to take through its full hypersonic experience. It's going to go into a facility and be exposed to hypersonic enthalpies, 1,000 degrees centigrade. Building that module now, we're working the facility end of it now, and that's a super important milestone for the company. The core engine, which is a very complex system of turbine machinery, smaller heat exchangers, circulators for helium, and such like, planning to build a core engine and put that to test by 2020. So the first milestone is in the next 8 to 10 months, the second one by 2020, and then we bring the rocket system along and integrate that around 2021. So this is a really challenging thing for a company of 120 people to be thinking about doing. We've got a great program that we've shaped with our funding agencies. We're recruiting like mad, recruiting some very talented people, some incredible experience from the space sector, more classic aerospace and other industries. And we're planning to build a partnership. So we're actually actively seeking partners for the program at the moment. And it's a combination of novel technology and stuff that will be very familiar to any of you in the world of aerospace. And it's a great challenge to have, actually. It's really fired people up. There's tangible things to aim at, particularly that demonstration in 2020. Just to add to the challenge, we've decided to build our own test facility. So we're building a test facility about 40 minutes from our site at our rocket propulsion test site. It is unique. It's a cryogenic facility enabling hydrogen-fueled rocket engine testing, hence the large footprint. We'll have an assembly building, it'll have a remote control station because of the hydrogen, and we did the groundbreaking about 4 weeks ago, so this is on. The road is going down now. I dug one spade full of dirt, there's another 1,000 tons to come out, so hopefully they've got the big boys in now. Actually, it was even worse than that. I dug a pre-prepared pile of dirt, actually, so I didn't even have to put any effort into it. It was actually, and then drank a glass of champagne, so just perfect groundbreaking, actually, everything. Although, having said that, when the Rocket Propulsion Establishment was set up in 1947, the first spade they dug in the ground dug up a dinosaur. And that stopped proceedings for about 6 months while they excavated this dinosaur skeleton. So I did say to the guys, just be careful. If you find any bones, or even worse, if you find something that's moving, don't, like a newt or something, don't tell anybody. We've been through planning permission, we've had all those hurdles, and we just need to get on with this. So this will be amazing to see this thing up and running. It will have other uses as well, so it's not just for our own benefit. We are re-energising that site, that Westcott site. We are converting it back into a true rocket propulsion establishment. We will be there. Moog are already there doing satellite propulsion and airborne engineering, who do a lot of our nozzle and combustion system testing. Airbus are putting down roots there, European Space Agency, UK Space Agency. This is becoming a real centre of activity, particularly for space propulsion. So great, welcome. Not all at once, but if anyone wants to come and visit, then we can certainly arrange that. So engine demonstration on the ground, and then the obvious thing to be thinking about next is are we going to go fly this thing? So I'm not saying, in fact, I guarantee this isn't the flight test vehicle, but yeah, we absolutely want to go and fly this thing. So who's going to be involved in pioneering, designing, executing that flight test program, which we are talking about doing in the middle of the next decade. So that is not far away, actually. On aerospace timescales, we're talking mid-2020s to be flight testing a SABRE engine. Now, we have an investment in our company from BAE Systems, so we are working very closely with BAE Systems on what that might entail. And that's great. That investment was much more than a financial investment. We actually get to draw on the capabilities of BAE Systems, their expertise, have got our arms around some of the team that worked the HOTOL project, which is amazing, and they're totally up for this. They deploy engineers into our business, and they've been outstanding, those engineers. So this is something we're all very, very excited about, and are starting to put into motion now. So there's a hell of a lot to do. We've got the challenge of growing a business. I will have to do another fundraise at some point, so and we've got some very loyal investors, but who've been very patient. But I have to go seek some new investors as well on the next raise, and find some application for that amazing heat exchanger technology. I really, really need to make that stick. So please follow progress. Please ask me some questions. I used to be an engineer once upon a time. I might be able to get away with saying I'm not an engineer anymore, but I'm fascinated by the engineering. And yeah, just join us on the journey, please. We are a good news story at the moment. We're a non-threatening British company that's highly innovative, that's a new space company, doing, I think, amazing things and being part of that growth of the space sector in the UK, the generation of high-value jobs, apprenticeships, inspiring the next generation. Tim Peake is a huge fan. He's visited us a couple of times. He sends people our way a lot. And I was privileged, actually, to collect an award for him, Lifetime Achievement Award. How do you get that after 2 years in the company? For Alan Bond, actually. So Alan Bond, who founded the company and is with us, received a Lifetime Achievement Award for his contribution to space and his efforts to take the SABRE engine and Skylon forward. So although I received it from Tim Peake, I was very pleased to hand that over to Alan in front of the whole company last week. A well-deserved award and very popular vote, actually. So thank you very much for listening to me, and I'd love to chat some more with all of you or any of you that are interested, and I think I can take some questions, actually.
Mark, thank you. That was truly fantastic. We have time for questions. I'm sure that's generated some interest. So who wants to start the questioning? Yes.
Helium turbines, in conventional turbo machinery, when you've got tiny blades in your axial turbo machinery, you start to think that, well, would a radial be better? What's the answer in your situation?
Mark, sorry, just for the benefit of the recording, I'm just going to, and everyone to clear. The question was about the challenge of helium turbines, especially the scale we're talking about. Have radial turbines been considered?
Yep, so that's a great question. I mean, this helium turbine is a really novel device, and the challenges are extraordinary. So we've worked up, I would say, about 12 different design concepts, but the preferred solution, because of that issue with the number of stages, was to go actually for a contra-rotating statorless turbine, which shortens it considerably but brings other challenges. But radial is being looked at because of exactly what you said there. Yeah, managing tip clearances on blades that are a few centimetres long is a huge challenge, actually. So we are looking at that, and we have actually commissioned a piece of work, a funded piece of work, to go explore exactly that territory. So.
Question about bird strike, and I'm sure several of us have got that question, Mark.
So let me just, what may not have been completely obvious, and this is trying not to, I will answer the question. Where the air enters the heat exchanger radially, so it's not a direct on airflow, it goes radially through the heat exchanger, so it turns 90 degrees, and then turns another 90 degrees to go into the engine. So there's a degree of protection. Heavier objects may get flung further down the intake, and then the ramjet system has to be able to cope with those. But we are taking that heat exchanger through a significant amount of endurance testing, which includes will include shaker table work as well as foreign object damage testing. So we'll be firing things at it. It did sit on an outdoor test bed on front of a jet engine for about 3 years, operating for over about 2 to 3 years, and it had all sorts of stuff sucked into it, from birds' nests to small stones and other objects, and it coped remarkably well, actually. So if you unpeel it to its fundamental technology, which is very small diameter nickel alloy tubes with small wall thickness, they are very flimsy. If I pick one up, it would, both ends would touch the floor, but installed in that spiral arrangement is very sturdy and robust device. But no, the intention is to take it through that full campaign after this hot heat exchanger test, which is the next big milestone. So. And birds would be part of it. Sorry, I nearly forgot about the bird part. Bird strike would be part of that. So.
Thank you, Ed. In the back. Right, the question was the reliability of the heat exchanger, which you quite rightly pointed out is the key element of your system.
Yeah. So you've got to sort of condition your mind to think about space. So one of the challenges of stepping out of Rolls-Royce into the space industry is your benchmarks change significantly. So, if you were used to designing engines, and I almost can't remember the numbers now, but to last hundreds of thousands of cycles, you're now into the competition does one cycle, effectively. So can you be better than one cycle? And the missions are a lot shorter. So single stage to orbit is a 16-minute mission. Okay, there, 60 minutes there is a bit longer on the way back. So overall life on these things is much shorter, in terms of maximum. It's if you have a multi-use system, it's going to be a few hundred hours life. It does have to be super reliable because it has to operate for that life in its to its maximum effectiveness, or you are going to compromise the payload capability in the operation of the vehicle. So I think if you can recondition yourself to think the numbers are a lot smaller, effectively. But we are looking for we have designed and tested a heat exchanger that is 4 times the operational life requirement. So that's been demonstrated. Not at the full temperature threat level, but that's been factored in. So we are in a good place, and that's as a result of alloy development. So we've been working very closely with alloy suppliers to refine the alloys, the design features that we've introduced, and most importantly, the manufacturing process, which has gone through many changes and is just on a different level entirely to where we were even a few years ago. So as a result of things like the investment in that furnace capability. So we must be able to tick not just the performance and weight boxes, but the reliability, the life, the durability, and all those other things. But
thank you. Yes. Yeah, very, very good question. If you are building the engine, reaction engine, who is going to be your partner? Who is going to build the rest of the hardware?
Yep. So we talk to a lot of people. We try not to make enemies. We see. So I'm often asked, what do I think about SpaceX? Well, I see SpaceX, are on a particular mission and doing amazing things, and they're potentially a future customer. So all of those companies, the new space companies, as well as some of those people you might think of, prime aerospace companies, BAE Systems, Lockheed Martin, Boeing, they're all potentially in that space of designing, developing, building, and offering up hypersonic vehicles and space planes. So we do to keep all of those people in our minds, and we have dialogue with them, as well as on the European side, companies like Airbus. So these are the companies that are going to do that stuff, and potentially some new entrants as well. So I mentioned orbital access briefly. Really impressive, actually, startup from nothing to a consortium of companies that has plans to not just develop space planes, but also operate a spaceport in the UK. So spaceports in the UK are a big thing now. And we're looking at that company as a potential proving ground for the SABRE engine. So one of the options for flight tests might be in that environment with that company. So you got to keep the radar on all the time. I mean, it's an incredibly dynamic business, and some of the people that are there today may not be there in the future. There may be other contenders, but we are. I guess prime aerospace companies and new space companies are our target market.
Thank you. Any other questions? Yes. David, go first, from Bristol Space Planes Heritage.
Presumably, the competition is having a separate
Yeah. Yes, that's right.
presumably the advantage of SABRE is lighter. So have an idea how much lighter?
The question is about comparative concepts to get to Mach 4.5, the 2-stage. Is SABRE lighter, which is its differentiating benefit? How much lighter? So, Mark, do you want to talk about some of the competitive benefits?
Right. Yeah. So if you can think back to that performance chart, you're absolutely right. Although, scramjets and the technology you're referring to, combined cycle turbine engine, a jet engine combined with a ramjet or a faster jet engine, or some combination of those things is really where the eye is focused at the moment, particularly in the US. So those are arguably competing systems. And yes, we think the SABRE is a simpler proposition or simpler offering. You know, it's a neater package and it's a more elegant solution. It's lighter weight overall, and if you extrapolate that to the vehicle savings, then you get orders of magnitude more benefit. But those other devices will have their place. You know, they will go through development. They will find applications. Ours is very clearly aimed at a highly reusable vehicle of some description. So where we have performance and weight advantages, but we are probably at the more expensive end of the scale in terms of the system, overall system. So you have to be aiming at a reusable vehicle. And I will have the numbers, and you can probably calculate them from that simple thrust-to-weight chart, actually. That gives you broadly the territory we're in. Maybe there's a 2-to-1 benefit or something of that order. So.
Thank you. I think there's some other hands up just in front. Question about constant volume pulse motors, pulse detonation, presumably.
So they are not with us though. So I think that is another system I could have introduced actually. So these are the sort of more in the pulse detonation type range. Yeah. So we're not studying them actively, but they are out there and are starting to emerge actually. So I think something we need to keep an eye on. Yeah. Allegedly there is one out there, allegedly. So that's interesting. I mean, without sort of going into a different mode entirely, we're talking about I'm talking about hypersonic vehicles, reusable space planes, but just a few months ago, the X-37 returned from 2 years in orbit, and that was pretty impressive that thing had been up there for 2 years doing whatever it was doing, and I can't believe that's the only one of those things out there, So the technology is starting to feel much more real than it did even a few years ago. So
we'll go there. Question about diversity in the company.
Yeah,
25% females.
I don't know actually. That's a really good question. We've not set off on any particular mission. We have had a great outreach activity from very very early days. So I think that's we really wanted to genuinely inspire people to take the STEM subjects and there's something about the space industry where it feels if I can say it, a bit less threatening. It's something that there are so many opportunities. There's this collegiate, welcoming, sort of almost team atmosphere in the space sector. And I think we've just sensed that the female engineers, if I can say it, are more prepared to step into that environment than some of the ones where they would think, believe, or know that they are more male-dominated, if that makes sense. So we've done really, really well, and I'm really proud of it. And by the way, the rest of the engineers are going to kill me when I say this, but 2 of my best engineers are both female. They're absolutely outstanding. These are women, girls that run teams, projects, technology programs. They deal with suppliers, they deal with partners, they produce contracts. It is as big as it gets. Really, really impressive stuff, actually. One of them is ex-Rolls-Royce.
Yeah, Liz, and then we'll go to the back. Question from the live feed. Wow, this is a Barnwell first. I'm excited, Liz. So, question about business model for reaction engines. How are you going to take this technology forward?
Well, I'm right now living and breathing my business plan because if I'm going to go out there into the world of investors and seek another, I won't tell you what the number is, but some billions, then I need to have a good business plan. But without giving too many secrets away, broadly, we will be a company of 2 parts. There'll be a programs piece to the company based around SABRE and similar offerings. SABRE is seeking a program, so that's the reason we're doing the work we're doing. The reason we plan is to demonstrate by 2020 we want an entry into a real program or programs, and there'll be a technology business, technology and innovation, which is more about spin out other sectors. Some of that will be near term, maybe short-lived, but other things will be longer term, and who knows how big they might get. So, and if I'm trying to appeal to investors, they kind of want to see that portfolio approach, really. it's a hard thing to pull off, because on the program side, I need smart people, great engineers, but it's about delivery, delivery, delivery. Get the milestones, hit the milestones, so we can get paid, so we can move on, so we can move into development robustly. And then on the other side, it's a bit more creative. It's a bit more blue sky. It's I want 20 ideas a day, but I'm happy for 18 of them to fail at the first hurdle. I just need you to fail fast and learn from it, and let's make some of them stick. So it's a difficult business to manage that might become two businesses at some point, but that's the way it's travelling at the moment. And it's off the back of significant government investment, which helps, the backing of BAE Systems that helps, and some real proven demonstration, actually. And I have an office in the US, which is very active, and I think that's another rich, target-rich environment for us. But
Thank you, Liz. We go at the back first.
yeah, okay. Yeah.
Okay, question about STEM outreach. In 40 years, we've stuck at the 9% mark, and as Mark's already said,
Yeah.
within reaction engines, it's 25%. So,
Yeah.
where has the industry failed, and where has reaction engines
well,
been successful?
We may have just been lucky. I'm not saying it's a direct product of what we've been doing, but I think it is time for a slightly different approach. There is great stuff that happens. Women in Engineering Day is great. We always support that, and we always get great projects running, and it normally has a return. But some of the other things, Tim Peake going around schools and talking to schools has had a phenomenal impact on the number of people that want to do science-based subjects. Now the return won't be seen for several years, but that is a different way of going about that job, I think. There's something that was very visible. He made a big thing about education, STEM and outreach. He talked to schools from the International Space Station. Actually resulted in the best question I've ever heard anybody ask an astronaut, which is a school kid, live link, saying, "What's your favourite button on the space station?" Which I thought just such a cool question. And the big, yes, actually, well, the big red one, I think, was it, but he was not allowed to touch it. But no, that sort of stuff could well make a difference, actually. That sort of different approach, and just a charismatic guy. And I won't sort of talk any more about Tim, because there's other astronauts all doing the great stuff. I don't know. We just have to have these inspirational projects. I think Airbus are doing something great at the moment in terms of visioneering. They're trying to describe the next 80 years of aviation, how and things that might come along. And because actually, there's a good chance. And I'm talking about aviation really, that people won't be inspired by a replacement for the A320 or the Boeing 737. But they might be inspired by something that looks very visionary and futuristic, and want to be a part of that, So I think a few different things required. But there's a good chance we've just been lucky. But we do have a very entrepreneurial culture, where we it's very startup in terms of its nature, and that does appeal to people who aren't quite ready to step into perhaps big industry.
Crikey. There first. Challenge about how novel you are, certification standards, and moving that forward.
You're absolutely right. I mean, what's the biggest general challenge people face stepping into this different world that I faced? But when I stepped from 25 years with Rolls-Royce, with this amazing company, this almost institution that had become my life, really, there was a lot of trauma leaving. There was this complete refreshment when I arrived in this new environment that was so different and dynamic and free of, I guess, rules and process and procedures. But then anxiety kicked in really quickly. we really need some of that stuff. That stuff can be good if it's done appropriately to the right level. So the two you mentioned, design process or the engineering process is really key. And we're working very, very hard to define the right design process for our company before we go much further in the program, looking at the best of the best in the industry. So it may not be the Rolls-Royce solution, it may be a combination of things, but it has to be done to the appropriate level and it has to be done robustly. And then certification. There are no certification rules currently that cover the types of vehicles we're studying, so we're helping to write those. So we've had, for the last 3 years, so before I joined, a joint activity with the CAA and through that connection to EASA and others to write the certification rules for space planes and their propulsion systems, be involved in that activity. And the government is playing a big role in that because in enabling, encouraging growth in the space sector and wanting to see operations from the UK by 2020, so launch operations, they're helping to push along the regulatory framework that's going to make that possible. So it's an area of intense activity. It's if anyone's brave enough to step into it, there is a lot to do, and it's we welcome any expertise, but there are groups actively working that now, actually.
Thank you. Apologies, we're almost timed out. We'll have these two questions here, and I'm afraid we'll have to curtail it then. So do you want to go first, and then we'll come here?
Yeah.
Excellent question. You quoted $10,000 per kilogram payload as the current norm. What can Skylon or your technology deliver as a comparator?
So we've always set off with the objective to be an order of magnitude cheaper than the cheapest system. So that's a moving target, with all of the developments in it. So already, and the numbers are not widely available, but reuse of a conventional rocket will take you into halving the cost effectively, somewhere in the territory of $5,000 a kilo. So we need to be sub $1,000 a kilo to low Earth orbit. That's the point we're aiming at, or thereabouts. But we need to offer other things as well, so other differentiators. So one of the key differentiators is flexibility in every sense. So the ability to flex the mission, the ability to take off from any spaceport, the ability to carry a small cargo as cost effectively as a large cargo. So I think what we're saying is, we have to actually dial in those other improvements and differentiators to be really there with a competitive system. But it is a moving target, and there's some amazing efforts at the moment in the industry to drive that cost down. So.
Clearly your company is cutting edge, you're doing new stuff all the time. I was just interested what reaction engine's strategy towards intellectual property protection is. Whether you can or you'll just rely on that speed and keeping ahead of everybody else.
Yeah, another excellent question related to intellectual property. Being such a fast-moving, dynamic company, do you patent widely, or how is your approach to intellectual property, or do you just rely on moving so quickly with what you do?
Yeah, so it's a fantastic question. We do a bit of both, actually, and I spend a lot of money on two big topics. One is intellectual property patent protection, the other is cyber security. Those are two big cost items for me. So we have a number of live patents that we're protecting and in UK, US and other domains, and that costs us. But we have quite a lot of know-how as well, particularly in the manufacturing processes. So there's very few people that understand the manufacturing process. It is very closely guarded. Those people are incredibly talented, and we want them to stay with the company, obviously. But so it's a combination of things. But the patenting is becoming more and more important, a bigger and bigger piece of our agenda, particularly with our technology business, where we need to get that stuff locked down so we can exploit it. We can exploit it directly or through licensing. Yes.
Thank you. I think the number of questions says it all, Mark. We could have stayed for an awfully lot longer. So on behalf of everyone here, thank you so much. We are very proud of our Barnwell lecture in the Bristol branch, and a long history of excellent lectures and events. And thanks for keeping the tradition going and more. It was a fantastic lecture. Entertaining, very, very interesting, but most of all, I think it was truly inspiring. I was looking around the room as you were talking, and everyone was hanging on every word. It's a fantastic story. We're all with you. We can't wait to see how this turns out. We wish you every success. So thank you so much for giving up your time for this evening and giving such a fantastic lecture, befitting of Barnwell. You mentioned at the beginning that you were recruiting. I fear you may go home with a number of business cards and CVs this evening. Just to my 20 Rolls-Royce colleagues in the room, don't you dare. But no, seriously, fantastic. Thank you so much. And on behalf of everyone here, thank you. And thank you to everyone here. The bar is now open. We're going to the bar. Mark's going to log on to YouTube and answer all his chat questions. We're going to sit down for dinner shortly after 8 o'clock. So please enjoy a drink. Mark's going to be around for the whole evening, and I'm sure he'll be delighted to take any further questions. I'm sure there are more. So please enjoy the rest of the evening. Those that are staying for dinner, it will be a great evening. Those that aren't, feel free to stay around at the bar and chat. And I look forward to enjoying the rest of the evening with all of you. Thank you.